Hi everyone and welcome to Chem class. Just want to look at questions to do with the counting unit of the mole, but don't necessarily involve one of the formulas that you have potentially begun to learn about to do with the mole. I find these ratio kinds of questions can be a little bit confusing, so I'll attempt to work through them and draw them out, see if we can get some strategies for tackling them. Let's have a look at this question. In 2 mole of C6H12O6, so glucose, so in 2 mole of glucose units, how many moles of carbon are there? So we've already counted how many glucose molecules there are. There are 2 mole, and we could work out how many particles that actually is using our formula with Avogadro's number in it. But the question's not asking for a different unit. It's asking about something in that molecule. It's asking about the carbon. My suggestion to you is almost forget the mole bit. Just use numbers and 10, 20, 100, just a number that you're quite comfortable with working with. So if I had 2 glucose molecules, how many moles or how many carbon atoms would I have if I was thinking about it that way? So what we have to do is think about it in terms of this molecule, which is almost like a family. And in that family, there's the 12 carbons and, the 12 hydrogens and the 6 carbons, the 6 oxygens, and there's just plenty of those all floating around. So for each one, there are 6 carbons. So if I counted how many of these, and then I want to know about the carbon component, I just have to multiply that by 6. If I had only 2 of these, how many carbons? 6 plus 6, I have 12. If I had 100 glucose molecules, how many carbons? 600. I'd just be multiplying that number by 6 every time. The mole is just a counting unit, so I can do the same thing. It means that I can take that 2 and just multiply it by how many carbons I have in each glucose molecule. And that's why we have 12 mole of carbon if I have 2 mole of glucose. Let's look at the hydrogen. So in each glucose molecule, I have 12 hydrogens. So if I had 2 glucose molecules, I would have 24 hydrogens because I would just be multiplying by 12. So in my 2 mole of glucose molecules, I'd take my 2 and multiply it by 12. So again, just my strong suggestion to you is to almost draw out that molecule a couple of times so you're visualizing this is like a family with lots of bits and pieces in it. And I've counted how many of those families I have, and now I just want to know how many of that particular item inside it. So I just need to multiply by how many I have in one. Let's do the reverse though. A question where we're doing the reverse is where I have a set amount of a particular atom and then I want to make a molecule out of it, knowing that in that molecule I might need more than one of that particular atom in each one. So if I've got 10 mole of hydrogen atoms, or think about just as 10, I've counted 10 hydrogen atoms, and I want to know how many water molecules I can make, or in terms of mole, how many moles of water I can make, we see that for every water molecule, we need 2 hydrogens. So I have 10 mole of it, but I need to use 2 every time I make a water molecule. So I could almost draw out 5 of these. Okay. So if I had 10 hydrogens, I could make 5 water molecules. I've had to divide that 10 by 2 because each molecule needs 2. So if I've got 10 mole of it, because it's just a counting unit, I can take my 10 divided by 2, which means I can make 5 mole of water. In the case of methane, which has the formula CH4, I need 4 hydrogens every time I make a methane. So if I have 10 mole of hydrogen atoms, I can't make 10 moles of methane because I need 4 every time. Following the same idea, I take the 10 mole that I have, I divide it by how many I need in each particular family of atoms that's bonded together in this molecule. It means I could make 2.5 mole. It's perfectly fine to have decimals of that. It's just a counting unit. If you wanted to work out how many molecules that actually is, you'd be multiplying that by Avogadro's number. Okay, hope that helps.